Good morning, everyone. I'm Michele Gattullo, and I will chair this session, whose topic is Art and Museum. Sorry for this little delay. We had some technical problems with the audio, but I think they were solved. I want to present the first. We have 4 presentations in this session. The first paper is presented by Shubhangi Garnaik, and the title of the presentation is Art Speak, an interactive AR application for lifelike speaking with art portraits. The floor is yours.
Yes. Thank you very much. Hello and welcome everyone. So usually when visitors go to a museum, they might feel lost if they're not really aware of all the art portraits, or say they go with a guide. It can be very time consuming because they have to go with a bunch of people. And lastly is when people have to read through textual descriptions under each art portrait. This makes the scenario for a person to go to an art museum very tedious. And hence, this has led to about 77% declined visitors in over 100 popular museums across the world. So there have been some research done to increase user engagement. The first is the variable museum. Here, they use Arico QR code markers and have illusion content put onto a physical space. Here, if you observe, each of these art pieces are not identifiable, and AR glasses that are used to view these art pieces are not accessible to all. The second example is Devata AR. It's an AR application for a Bali temple. What the application does is it has a 3D model of the temple, which is projected onto the brochure's image marker. While these two solutions are a pioneering step to have user engagement, they yet lack personalization, they have no conversational interfaces, and overlook the latency issue. We want to overcome these issues, and hence we developed the ArtSpeak application to have self-explanatory art, a personalized interactive storytelling experience, and an application that's flexible and accessible to all. If you look at the image on the right, you would see that a person is trying to scan this art portrait of the Laughing Cavalier. It's a painting by Franz Hals, the famous painter. And here, if you look at the cell phone, it shows a bunch of text, which is, again, a very tedious process for some to go through. What if I told you that an art can speak to you instead?
The Laughing Cavalier portrait reflects the subject's joyful
To
expression.
have this application in place, we first had a generative AI model, which basically helps to make realistic talking faces execute in real time on an RTX 4090 GPU. This process of video generation takes about 1 to 1.5 minutes, which leads to a massive latency of 1 to 2 minutes on the user's end. This leads to a certain level of user dissatisfaction. Now, to improve the scenario further, we had the generative AI model deployed onto a server, H100. In this case, we did see a drastic reduction of video generation time to about 8 to 12 seconds. However, on an average, it takes about 10 to 15 seconds to render on a user's mobile phone, again leading to some level of dissatisfaction. So to avoid this latency issue, we introduced generating FAQ list and a video database in an offline scenario. So here, given a certain art portrait, we generate a list of FAQs using ChatGPT for across user personas. It could be a person who is very aware of art pieces, probably someone who doesn't know about it, someone who's younger, someone who's older. So range of FAQs that you could think of. Obviously, we did go through and filter out any repetitive FAQs. so that we have very concrete, specialized question and answers that users could ask and get responses to. Now, these answers in the FAQ list were converted into realistic talking head videos using the SAT-talker model. And this whole process was done in offline and stored into a video database. So in our approach, what we did is have all the computationally expensive process done offline. And now when a user simply scans an art portrait, they would have a response provided within 2 to 3 seconds. This increases user satisfaction rate. Here you'd observe that we entirely removed the video generation process, thus leading to an almost real-time experience. However, there are situations where a user could have a query where part of the query has a response in our database and a part of it wouldn't have a response. In that case, initially, the response existing in the database is played on to the user's end, and parallelly, the part of the response which is new is generated in real time. While this happens in parallel, this reduces the latency visible on the user's end, and hence this increases user satisfaction even in adaptive response cases. Now we look at the FAQ-based response system that we used in our application to improve the user experience. As discussed earlier, I already have an input of offline video database, which is provided as an input to my FAQ retrieval system. In real time, what happens is when a user asks a question, our retrieval system finds the closest aligned responses using a technique of cosine similarity between a sentence embedding of two sections. Say like, in this case, say the user's query and the possible responses that could be that could help to answer the user's query. These videos are retrieved from the database, put into a video playlist, and provided to the user on their application. Now, you would observe that while we create new user responses for queries that haven't been seen before, the video database increases in size. However, initially, when we had the initial video database, it would be able to respond to about 80 to 90% of users. And now, as a video database increases, it is able to answer a broader range of responses, nearly about 95%. Our entire application was developed in an aim to reduce power consumption on the user's end, because it's a mobile application, and reduce the latency so that we can have user more connected to the application and actually enjoy the experience. So you would observe here that we had a power cut down of about 1/4 the original requirement, and we had a latency reduced to almost real-time experience. This led to a great user impact where we had about 23 people use our application during a user study, of which 90% agreed to having satisfied experience across scenarios. Say they had a direct response or the response was generated in real time, our application's responsiveness, and their overall experience while using it. Now we'll have a short demo of the application.
Why is it called the Laughing Cavalier, and who painted it?
The Laughing Cavalier portrait reflects the subject's joyful expression and cavalier style. Painted in 1624 by Frans Hals, a celebrated Dutch golden.
In conclusion, we developed a novel augmented reality application for museums that bring portrait to life. Additionally, we are able to have our application respond to user-specific query with relevant information. The application design is very user-friendly, which helps anyone adapt to using it, and our application has a very minimal computational requirement. In the future, we look forward to instructors using our system to create interactive lessons, people using our system to use it in interactive business cards, poster presentations, or have enhanced AR video calls. Additionally, we do look forward to improving our current system to use unsupervised personalization for adaptive user experience instead of annotated data. That's it from me. Thank you very much.
Thank you for this presentation. Is there any question from the audience? Okay.
Thank you for your presentation. Well, I'm from Holland, so I'm a little bit proud to see our painter depicted here. I have a question about the input of the query. Is that done by voice input, or does a user have to type it in?
Yes, it's a voice input, which is converted into text in real time, and then the text is matched, and the whole process of FAQ retrieval system that I discussed.
Yeah, that sounds good. And another thing, but that's more for maybe for some future direction. Would you consider having the person in the painting talk themselves from their own perspective? Like, hi, I am this. This is my name, and I'm being painted by Frans Hals, and this is the age, and I'm wearing my best clothes, and my head itches. Those kinds of things, to have it more personalized, to have more like a one-on-one conversation between the looker, the visitor, and the depicted person.
That sounds like a really good point. I think, like, going further, that would be a great addition to actually get a user hooked on.
Yes.
And then they could start using it.
That would be great. I'm looking forward to hearing about it.
Thank you so much.
Other questions? Yes.
Thank you so much for your interesting presentation. I just have a question. Usually in museum, like you want to look at the real painting and admire the details. So don't you think having to hold the phone and look at the painting through the phone kind of affects the museum experience?
Honestly, I think what you're saying does make a point, but I only believe that people do admire, look at the painting, and then have questions. And that is when our application comes in place, to help them navigate without anyone additional around.
Okay, thank you.
Thank you very much.
Like building on her point, but why is AR necessary at this stage?
So it's
Only to identify the image, you mean, or?
yes, mostly to identify image and to also kind of have that whole experience of an art speaking to you. That is one of the reasons that we used AR over here.
Okay, another question.
Yes.
Did you keep track of what the people asked and kind of compare it with, so in the real museum there's most probably something that is written, right?
Yes.
That explains it, and like kind of compared what type of information they were able to extract and like compare it to what was actually written, like and to get some insight on how much they learned more, for example, and relevant for themselves? Were you like, is this something you considered or something you looked into?
So I considered a part of it where the details that they usually have under each art portrait and what we generated, the whole list of FAQs, how much do they really answer to questions? Our FAQs, obviously, because we had the entire control of taking care of what sort of informations we can provide, what additional things people might be curious about. So we had like an extensive FAQ system that could respond to more questions. However, again, the description was very like static and rigid to that point. However, looking further, I think it would be better to have further studies into that line of thought process. Thank you so much.
I also have a question myself. Really nice presentation, thank you. But from my understanding, there are also other applications that uses AR or image detection that kind of make the painting speak, but not like the painting speaking themselves. They use Gen AI to kind of like do a chatbot kind of thing. So you can actually text them and also like get replies, which kind of helps with the latency and doesn't really have the issue of like the real-time video rendering stuff. There's also audio-based ones that doesn't have any visuals, which have way lower latencies. So what do you think is the points of like doing the video rendering, which causes latency, since that's a huge issue. I think
Yes.
that's what the paper is mainly about. So
Perfect.
yeah, I was like, why is like comparison? Why do you think video is necessary in this
That's
case?
a very good question.
Thank
It's I wanted this application to be accessible to all, so it would be like small kids, older people, and almost anyone who might not understand that, oh, latency is a problem that I need to think of. They are more of into the fact that I want to enjoy this experience of coming to an art museum and learning about arts. So given that, I did observe, like there was a paper that did talk about how people interact in textual, audio, and video form, and they did see like a maximum level of engagement was appreciated in a video form because they had like people catch their attention more quickly as compared to text and audio. But that's a very good point. That's something we did look into.
Yeah, thank you for your answer.
Thank you so much.
Okay, thank you again, Shubangi, for this nice presentation.
Very much.
Okay, and we can go to the second paper in this session.
Yeah.
So, hello everyone. Unfortunately, the author of the paper cannot attend ISMAR in person due to the visa issue. So I will present the paper instead for them. And the authors make a QR code on every page of this presentation. So if you have any questions, you can just scan the QR code and ask question to them. It's an online chat room. So the authors are there waiting for you. Okay. So this study investigates how emotion-driven interaction can enrich virtual music experiences and reshape the way we perceive and create art. Virtual reality has transformed how we experience art. By providing immersive visual and auditory environments, it allows audiences to appreciate and even recreate artworks in new ways. For instance, the night cafe, the screen, and the beautiful spring down in the Ham Palace. All of these examples demonstrate how VR can extend traditional art beyond static viewing, turning two-dimensional images into living, interactive spaces. However, many existing VR museum systems still suffer from limited immersions and interaction, making the experience less engaging than intended. This gap motivates our exploration of artistic interaction, aiming to go beyond visual fidelity and to foster deeper, more effective engagement between the artwork and the viewer. In most virtual museums, users are still viewers rather than co-creators, and as a result, artworks often lose their unique emotional presence. What Walter Benjamin described as aura of authenticity, the artwork's power to emotionally look back at us. In virtual environments, this aura can easily fade through reproduction and simulation. However, as shown in the figure, media design can also enhance or reconstruct aura, shaping both how authenticity is perceived and how deeply users engage. Building on this understanding, this raises a key question, which is how can we revitalize artistic experience in VR to restore the sense of aura? Our answer is to let users emotionally co-create artworks in real time, making their own feeling part of the artistic process. To test this idea, the authors conduct a between-subject experiment with 48 participants. They focused on two research questions. The first one is, does the emotional feedback module enhance participants' emotional state during VR-based artistic recreation? The second one is, which component of the interaction design, visual, auditory, or interactive, has the greatest impact on users' emotional responses? Participants were randomly assigned to two groups. The control group explored the museum in free roaming mode. The experimental group experienced the same museum enhanced by the emotional feedback module. Both groups had identical basic interactions, grabbing the objects, reading descriptions, and customizing room layouts, though that the emotional feedback was the only independent variable. The authors proposed a new VR paradigm that directly integrates emotional feedback into artistic recreation. In this system, users' facial expressions are captured in real time for emotion recognition. The system then performs effective adaptation, dynamically adjusting visual, auditory, and narrative elements according to users' emotional state. Through this process, users don't just observe art, they co-create it. Their emotion continuously reshape the artwork in real time, resulting in a more personal and authentic artistic experience. The system first captured the user's emotions in real time through facial recognition, then translate that data into dynamic changes across the artwork, visual, sound, and the environment. This ordered virtual world, in turn, evokes new emotional responses from the user, creating a continuous feedback cycle between the person and the artwork. The system goes beyond the traditional visit by transforming users' facial expression, which is tracked in real time by the headset, into a dynamic force that alters the artwork. Users can freely explore two distinct exhibition rooms, a painting gallery and a sculpture hall. Beyond this core emotional interaction, they can also grasp artifacts for close inspections, customize the environment, and enjoy dynamically changing ambient music, creating a rich, multi-sensory experience. The authors designed 3 modules for the study. The first one is the tilting reinterpretation. Some classic artworks such as Mona Lisa are reimagined based on 4 primary emotions: happiness, surprise, sadness, and anger. When users smile, the painting brightens, and when they frown, it darks. The next one is sculpture reinterpretation. The neutral sculpture changes its shape and texture based on the emotions it detects, giving people a real, tangible sense of emotional change. The last one is 3D painting reinterpretation. Users can enter a Chinese ink painting. Their emotional state changes weather, tree shapes, and lighting in real time, transforming a flat image into a living world. This module embodies the idea of emotion as a bridge between the individual and the artwork. The findings indicate that the emotional feedback mechanisms they introduced effectively enhance participants' affective states, improve system usability, and strengthen their sense of presence in the virtual museum experience. To systematically examine these effects, the authors applied a set of evaluation tools. The first one is the visual analog scale for emotional states, and the virtual reality neuroscience questionnaire for usability, and the iGroup presence questionnaire for presence, and also a semi-structured interview for qualitative insights. The data revealed 2 compelling stories, one from within the experimental group and another from the comparison with the control group. The first one, the pre- and post-experiment comparison within the experimental group tells a clear story. All 4 positive emotions increased significantly, while negative emotions decreased. A notable exception was dizziness, which intensified. Then, when we compare the control group versus the experimental group, the conclusion becomes even stronger. The comparison confirmed that the emotional feedback module itself was the driving factor, specifically boosting pleasant and happy emotions while reducing sadness and digest. Now let's move from emotions to the broader impact of the system. As measured by the user experience and presence questionnaires, the results from the VRNQ and IPQ reveal a clear advantage for the experimental group. While usability scores were consistently high across both groups, the user experience was significantly enhanced when emotional feedback was present. Furthermore, in terms of presence, the experimental group reported markedly higher scores in spatial presence and involvement compared to the control group. In short, emotional feedback boosted both emotions and overall experience with high usability and no major drawbacks. To dive deeper, let's hear what the participants shared in their interviews. From the semi-structured interviews, we drew 3 main insights. For the first question about preferred experimental elements, participants ranked the 3D painting recreations highest, followed by interactive sculptures, and then 2D paintings. The ability to walk into a painting and interact with object was a big factor in their choices. For the second question on emotional impact, visual elements like 3D depth and spatial dynamics stood out the most. These effects were further enhanced by synchronized ambient music and gesture-based interactions. For the third question, suggestions focused on improving smoother audio-visual synchronizations, offering richer interactions options like haptic feedback and designing adaptive navigation features to help reduce dizziness. Altogether, these findings highlight how audio-visual quality, interactive flexibility, and smooth navigation can central to shaping an emotionally engaging museum experience. On this slide, I'd like to highlight some key findings and future directions. First, the author find that effective adaptability is more effective than static interactivity, meaning that when the system responds dynamically to users' emotions, engagement, and user experience are significantly enhanced. The authors also observed that both the visual and the interactive fidelity are critical drivers of emotional response. In other words, higher quality visuals and interactions make emotional response stronger. Based on this insight, we propose a redefinition of aura in VR. Rather than being a fixed property of virtual artifacts, aura is co-created through the interplay between user emotions and the interactive dynamics. Importantly, this has broad implications for domains like education, digital heritage, and mental health, where emotionally adaptive systems could bring meaningful benefits. There are still some constraints. Facial expressions can be masked and don't always reliably reflect emotions. The authors need to integrate multimodal signals such as EEG, GSR, and voice to capture emotions more robustly. Another open challenge is to disentangle whether the benefits they all observe come from true emotion matchings or simply from the system's dynamics. Looking forward, the next step will focus on integrating psychological signals into the adaptive pipeline and testing the system with cultural artifacts and real museum environments. This will help the authors to evaluate not only technical robustness, but also real-world cultural impact. In summary, the research proposed a new paradigm that makes emotion a direct part of VR interaction. It also implemented a functional system where users' emotion captured via the facial recognition dynamically transform 2D and 3D artworks. It also empirically validated the system, confirming a significantly enhanced motion engagement and user satisfaction. Together, they demonstrate that emotion-responsive interaction can profoundly enrich VR art and cultural experiences. And thank you very much for your attention. If you have any questions, you can scan the QR code, and the authors is in the chat room waiting for your questions. Thank you.